Okay, folks, it's 11:15 by my watch. We've got Mark Pocock here from Hersley, who's the Trust and Compliance Lead, who's going to talk to us about security enhancements for 6.2. Mark, I'll keep an eye on people coming in. I can set it to automatic to admit them, which I'll probably do now once you start talking. So don't worry about anything like that. If anyone's got any questions, you're all on mute, so I'll monitor the chat, and if there are any questions, I'll bring them up. But we've got 45 or 44 minutes now. Mark, if you can take it away, please.
Yep. Okay. Thanks, Rob. So, yep, I'm Mark Pocock from CICS development team. Taken over in the last release as the Trust and Compliance or CICS security lead. So previously that was Colin Penfold. You may have heard delivering similar presentations in the past. So this presentation is going to go over what we delivered in 6.2 related to security. So CICS version 6 as a whole had quite a big focus on security, and specifically around the areas of zero trust. And so there are a lot more changes coming in this area than you would typically expect from a traditional CICS release. So as Rob said, we've got limited time, and so hopefully we will squeeze everything in. So what are we looking at the main changes, main themes for the changes in 6.2? So we're looking at improving security and compliance management. So can we make your job of dealing with security and CICS easier, take away some burdens, give you greater security controls with less overhead, and importantly, in the current climate, can you prove that you are set up in a particular way? So can you prove that you've got this particular level of security? Can you prove that particular checks are taking place? When it comes to auditing and other external bodies that may be interested in knowing your security status of your CICS regions. So the release has been split out into kind of two main parts. So the big focus on zero trust, where we've got some larger items. So that's the introduction of CICS security discovery. So that's a mechanism for finding out what security calls would be made on your system, typically, to allow you to then go through a process to try and add additional security that you don't already have. We've made large changes to the way ResSec and CommandSec are working for transactions. And then finally, we've got a pair of technologies that work together, which is security definition capture and security definition validation. And these are built on the security request recording capability that we had in 6.1 and allow you to add security testing into your development pipelines. So when your applications are being built and deployed, you can capture security definitions and automatically validate that there are no unexpected changes. So your development change hasn't suddenly introduced access to a different resource or changed the level of access on an existing resource that would then require you to have updated security definitions as a result. So we'll cover all those in a lot more detail. Those form the bulk of the release. But we've also managed to do some other security changes. So there's numerous changes related to TLS. We continue to do small changes to help simplify the whole process of securing CICS, a few around compliance and auditability, and then we'll finish off having a short discussion about where we are with our security documentation restructure. So zero trust at IBM, you can read the comment here. The word gets bandied about a lot. It isn't a thing. You can't just say, "Oh, here's zero trust." It's a way of thinking. It's an approach to securing your systems, rather than I've just done zero trust. It's not just a parameter you turn on and have zero trust. So you'll hear the statement that we got on the left here. Quite often it's all about enabling the right user to have the right access to the right data for the right reasons. Aiming to never trust anybody, always verify, and assuming that the bad actor is already inside. So historically, security measures have been aimed at keeping bad actors out. So you've had a perimeter security, but more increasingly, the bad actors are inside. So either they've got in via valid credentials, or they are, disgruntled employees or some other process that's managed to be running inside your infrastructure. And suddenly that boundary security is no longer good enough. And these internal actors who could appear to be legitimately signed on and legitimately accessing the system are now doing unusual activity. And that's where the continuous monitoring comes in to help flag up those types of anomalies. So there's a little jigsaw on the right, which has got the different pieces that make up zero trust. So obviously CICS is not involved in all of those. So we're not part of the infrastructure. We don't manage devices. And while we're an endpoint on the network, we're not involved in network topology or network infrastructure and things like that. So CICS is not involved in those, but we are involved in identity. So CICS manages user identities and their authorizations. Obviously, we manage and run applications, and we provide access to critical data. So those are the three areas that make most sense for CICS to be focusing on and providing capabilities to allow you as CICS system programmers to adequately secure. And all this move to zero trust, focusing on zero trust, is all backed up by research in the security sector. Just saying now that more and more attacks are coming in with valid credentials, so they're not even being stopped by the traditional boundary security. They're getting in because they appear to be real users, and most attacks can be avoided if you've got up-to-date security fixes, implemented MFA, and have what they call least privilege principles, which is zero trust, is you by default have no access and you only get the bare minimum access you require to satisfy your job role, and not kind of either having no checks at all or having blanket access that's far higher than needed. Okay, so let's get back to CICS 6.2 specifically. So the zero trust section covered these three areas. So we had security discovery. So we're aiming to help you improve your role-based security. We want to identify resource security definitions that are needed in production and provide an estimate of the cost of adding resource security. So many of you that will be fully on board with the idea that your resources should be adequately secured, but ultimately that's going to come at a cost. If you just run with transaction security on now, and you switch to suddenly having all the resource security checks active, that's potentially a very large number of additional calls to the ESM to validate that an individual user has access. So how much is that going to cost you, and how can we assist in providing you with the means of coming up with an estimate before you start down that process? Because once it starts getting into costs, then that's more of a business decision rather than a CICS system decision as to whether you go ahead and put this on. We've also made significant changes to ResSec and CommandSec, and we're kind of encouraging you to move to a position where that you would code ResSec and CommandSec always in the SIT. So you always want them on, and we've had to make changes for the CICS supply transactions, and in many cases we've removed unnecessary security definitions. So that's all part of our simplification, taking away definitions that really aren't needed. But there's still some that are required, and we'll go over that shortly. And then the final bit I've already said is that security definition capture and validation working together to identify the security definitions you need during development and be able to fit in with some sort of automated test process to allow you to verify that new developments haven't altered the security requirements of the application. So Zero Trust fits in with CICS primarily via resource security. So we've talked about transaction security being the main thing that was used with CICS, and that's a form of boundary or perimeter security. So once you've signed on, and then once you've been authorized to use the transaction, that transaction can do whatever it likes. We're not going to check any other resources after that point. So they have access to anything that you've got on the region, and then they can also go across to other connected regions and access whatever is on those regions. And with that model, you are trusting the application code to do what it's supposed to do, not go outside those bounds. But you're not really securing the data, and it's the data that's the critical important business resource here, and nothing has been specifically done to protect that. But we also recognize that most of the customers don't have resource security, so for a variety of reasons. So complexity of implementing, there's a lot of different options to turn on, particularly when it comes to the general resource class covered by the XRES SIP parameter. Because if you've got that active, then suddenly you need to have definitions for everything that it covers, not just one single type of resource that you get with, say, programs or firewall security. There's the CPU cost, which we've already mentioned. We'll talk about estimating that in a bit. And typically in the past, transaction security was sufficient. You had to sign on to the CICS region in the first place, and then you had to be allowed to run the transaction. And in many cases, that was good enough. So how can we make Zero Trust in CICS work? Well, this is all reliant on having well-defined user roles. So it fits in with that statement of enabling the right user to have the right access to the right data for the right reasons. And the user's access then should be related to their job role. And if they leave that role, then they should lose the access. And we've got a good mix. So we have some customers that will have a very strong set of well-defined roles, excellent processes for matching users to roles, continued business need, validating that they are still in those roles, managing when users join and leave particular roles, and tightly controlling the access that those roles grant. But then there's other systems where everybody is treated as an individual. There's no roles at all. or there might be some hybrid situation where you've got some roles, but you also have individuals being given access. So you see lots of those in probably older development type systems that have evolved over time. And yes, there are some roles, but somebody new came along, didn't appear to have access, so they were just granted access individually rather than finding out what job role they should be in. And you can end up that, and things change, but definitions in the ESM aren't updated, and things end up a bit of a mess after a while, with users potentially having accesses that they shouldn't have anymore, and it's very difficult to control or audit if you've got loads of these different individual accesses. Trying to determine should this user really have this access can be very difficult for the system programmer anyway. So the zero trust route in CICS is ultimately migrating to resource security, but that can be a tricky process. So you don't have resource security currently. Potentially you don't have good automated tests or manual tests, and potentially don't have any specific security related testing. So it's difficult to validate, if you go and make any changes, to validate that things are still working as they are before you head into production. We're trying to allow you to move towards resource security with some level of confidence, so that you could enable that in your production system, even if you don't have an extensive set of tests before you get that far. Have some confidence that you haven't broken anything, and that's the key here. You don't want to go and put in a whole lot of very strict resource security checks and end up in production and within 5 minutes nobody can do anything. So that's what we're trying to avoid, and that's what the facilities that we're adding here in 6.2 provide. So we'll start off with security discovery. So our security discovery process is kind of described there on the left. So we start off here by extracting your existing definitions out of RACF. So typically that's going to be transaction security, and we are making the assumption that you have transaction security active. So we're not aiming to start from no security at all. We are expecting so this is aimed at production systems, so we're expecting your production system to have security active. So we extract the RACF definitions that you've currently got for CICS. So that's typically the CICS transaction class, and then all of the users and roles that are associated with that class. And that becomes our input security metadata file. Then you can put that into CICS Explorer. So within CICS Explorer, we've got a security discovery perspective, and that allows you to analyze the definitions you've already got, reorganize things, make changes, alter roles, move users around, change permissions, to ultimately come up with a set of transaction access definitions that you're happy with, and come up with a set of roles and users within those roles that you're happy with. After that, you can capture security discovery data from CICS. So that's by activating security discovery within your CICS regions, and that will analyze all the security calls that are made and all the security calls that would have been made if security was active. Captures all that information, and then we can run a batch job and create a security discovery data file, an SDD file, and that can also be imported into Explorer, and that will then allow you to analyze the accesses for resources that you don't currently have definitions for, and allow you to create appropriate member list groupings. So putting your resources into member lists, associating access to those member lists with particular roles, and ultimately creating a new set of RACF definitions matching the requirements for accessing those resources. So we'll go and look through each stage. So the importing RACF definitions. So this is imported as a YAML file. There's a brief example there on the right-hand side. We provide a DFH $R to USM job. So that's RACF to security metadata. And that will go and grab everything out of RACF that's related to the listed CICS classes. As I said, we are assuming that you already have transaction security in order to do this whole process. You do need at least RACF audit authority in order to be able to get there, get all the information out. So this is viewed typically as a job that you would request a security admin to do for you. In most places, I suspect that the normal CICS system programmers would not have the appropriate RACF authority to run this job themselves. Capturing the security discovery data at runtime is achieved by activating the SEC discovery capability. So we've got an SPI to do that. So we've got a set, an inquire, and a perform. So set SEC discovery is turning it on or off, and also setting which resource classes you want to capture. So it can capture everything, but if you want to do this whole process in kind of a piecemeal approach, so you say, well, let's say, okay, I'm really interested in adding file security. So I will just have this monitor file access requests. So you can set the status to on, tell it to just discover XFCT accesses, and not bother with anything else, and it will happily go around and do that. We've got an inquire command, which allows you to see what the current status is, what's being captured, and the last times that we captured a piece of information. So we only capture a single instance for a particular user accessing a particular resource. So user 1 accessing file A, if they do a read of that file, then that's captured the first time. The next time they do a read of that file, we don't need to record anything. So this isn't a set of statistics. It's not a complete audit log. So that user 1 accesses file A 100 times. We're not recording that they've accessed it 100 times because we're only interested in the security definition required, and that was just they needed read access to this file. So we only need to know that once, so we record that once. All the others are just ignored when they happen. So we would expect in a production system, after a relatively short period of time, most of the accesses have been captured. So if you've got the majority of your users on and active on the system, and they've done most of the functions of their day-to-day job, then after that point, the new accesses of the recording will tail off, and that's the time that we can say, okay, I'll write all this information out, and we can start processing that in Explorer. The data is written out to a log stream. It's written out at when CICS shuts down, or at end of day, or on demand using the perform command. So after we've got our security metadata and our runtime data, then what are we doing with those? Well, we're analyzing these definitions in the CICS Explorer. So we import them in our CICS Explorer security discovery perspective. You can see a small screenshot of how that looks on the right-hand side. So you'll get a big table, and across the top, you've got the member lists and resources. So this is transactions. You can see a bunch of member lists there with a lowercase m at the start. These are all the ones that the CICS Explorer has automatically generated as part of an analysis that you ran. On the left-hand side, you can see a set of roles and users within those roles. So we've created a role called HR, another one called manager, sysadmin, and teller, with various users in there. And within the table itself, you can see there's some R's and R pluses in places. So the uppercase characters are indicating whether you had access in the ESM already. Lowercase characters are what we observed at runtime. And pluses means you're going to have to make a decision because someone appears to be gaining extra access. And once you've manipulated the data in Explorer, then we can export that and use another batch job, DFH$SM2R, so security metadata to RACF, and that will take the security metadata version of what you had in Explorer and create a new set of definitions to go into RACF. And we would recommend that you created a brand new group, so we wouldn't recommend that you updated your existing CICS group. We would say create a new class so that you could start up CICS with that new class, and if there were any problems, then you can restart CICS and go back to your old class while you work out what needed to change. And that's a lot cleaner than trying to merge in with the existing definitions in your current class. And it also means that once you're happy with these new ones, you can just delete the old class and fully switch over to the new one. We do provide a set of statistics. So I said we were going to aim to provide a means of helping you work out the cost of resource security. So as part of security discovery, we capture this information. This output comes from running the DFH$SDDP job, which creates the SDD file. But it gives you an overview of how many transactions you executed, how many checks you actually performed, and whether or not the class was already active. So it gives you an indication of the extra cost that would be involved. So we can see with this particular workload, there's XTran is active and XPPT is active, but there's 47 XFCT checks that would have been made if file security was active. So if this was part of a process to enable file security, you say, okay, well, I'm going to have 47 extra checks. There were 24 transactions executed, so pretty much 2 checks per transaction if you're just coming up with a ballpark figure of the cost of activating file security just on this small sample of workload. And we did calculate a cost. So approximately 2 microseconds on our system was the cost of calling RACF to do the resource check. So that's documented in the CICS documentation. So it's a fairly simple ballpark figure to say, right, okay, resource security is going to cost me about this much. Okay, moving on to changes to ResSec and CommandSec. So many CICS transactions are defined with ResSec no, CommandSec no. That was the old default. And in the SIT, our default for ResSec and CommandSec is as is, which means use whatever is on the transaction definition. So that results in many, many transactions not doing security checks, even if you enabled the SIT parameters to add in that type of check. So ultimately, we want you to move towards ResSec always, CommandSec always. But that's going to be a big impact on on your current on the current transactions, and also on CICS supply transactions. So we need to do a bit of work ourselves in order to make sure CICS transactions could fit in a ResSec always, CommandSec always environment. So what have we done? So we've made all the CICS transactions in 6.2 be ResSec yes, CommandSec yes. So that's our category 1, category 2, category 3 transactions. Many of those don't have security checks anyway, or don't have resource security checks anyway. So it's really a no-op. They're not accessing any resource that was protected. So telling CICS to do checks makes no difference. Some of them were accessing resources, but those checks are unnecessary because they're just a key part of running that transaction. So the entire purpose of running the transaction was to update this particular resource. It doesn't make sense to make you authorized to use the transaction and then authorized to use the resource as well when that transaction's only purpose. So in some of those cases, we've removed unnecessary security checks and said, okay, well, it's this application, so you can do its job. We provided compatibility group DFH Comp K to allow you to put the old definitions back into back level releases. And part of what we did to remove unnecessary checks. So one of the reasons we can do that is, example given here is the sign-off transaction that writes a message. That's one of its main jobs. It signs off and it writes a message telling you it's signed off. So you shouldn't need to have authority to be able to write the message out when that's just its purpose. So there's no point in forcing a security check on just writing out that message. Whereas Keki, for example, well, that absolutely should do all of its checks because there you're issuing any commands you like. So in terms of transaction definitions, we've changed the default for ResSec and CommandSec, so they're now yes. But that only affects new transactions. So existing transaction definitions you've already got are unchanged. Obviously, we would encourage you to review what you had and ultimately switch over where possible. And you can use security discovery or security request recording to find out what security checks take place in particular applications and allow you to make sure you've got the definitions in place before you change to ResSec yes, CommandSec yes. When you've got to a point that you are happy with ResSec, CommandSec settings, then really should consider changing your SIT values over to always, which then means that any new transactions or any changes to those transactions will be required to make resource and command security checks. Okay, the last big bit we've got is security definition capture. So this is aiming to help you identify security definitions for new applications. So, developers out there, I've got this application through. How do you know what security you need for it? Well, you've largely been relying on the developer writing down what they think they need and then probably submitting a request to go and get the appropriate security added. But there's the chance that they miss something. And certainly if it's an area where you currently have that security turned off. So it's how do you identify exactly what's required? And security definition capture allows you to do that in an automated way, so you don't have to rely on the developer just to tell you. So what we're trying to do is identify security definitions during normal testing. So typically it's on a development system. You've probably got Secable, yes, but you don't have very much else. You don't need to know anything about security, but you can use security definition capture, and we will just capture everything in the background for you. You can either interact with that via the terminal. So you can log on to your terminal, activate security definition capture, run your tests, and then turn it off again. Or you can use an HTTP interface to do the request to turn it on and turn it off. The RESTful interface is primarily there to allow this to be put in as part of a development build pipeline, for example. So here's a sample flow of the manual process. So you compile your code, you'd start the definition capture, you'd do your manual test, you'd stop the capture, you'd submit the jobs to format the output. You review the output, and then you can raise the request to your security admin for all the access that's required. The admin can review that, make the changes, and then you can deliver the code knowing everything is in place. So mentioned the two processes, 3270 and HTTP. So with 3270, we sign on. We use a CXSD transaction to turn definition capture on, run the tests, and then turn it off again. And that captures everything originating from that terminal. So that really is a manual process. The non-3270 process, so using a post and a delete, so that is not tied to the terminal, so that can capture a wide variety of activity, and that's aimed at capturing everything that a user is running. So that's the developer would turn that on, submit their workload, turn it off, and then process that. We've already seen an example of security metadata, so I won't go through that at this point, and we'll move on to the partner part of security definition validation. So the aim here is, in an ideal world, we'd have automated tests, and things would be running in a DevOps pipeline, and you'd have your code being delivered, run through there, automatically run tests, and get merged in and distributed if everything is successful. So we need a way of playing into that. So we've got an open source Galassa framework manager to allow that to work, to fit into a DevOps pipeline and do the security definition validation process. So this looks very different, very similar to definition capture. So you'd request a code change, you build the code, we'd again start the capture, we do the automated testing, we stop it, we submit a job, again we get the output, we compare that with a baseline. So this is what we thought the security was before you made your changes. Have they changed or not? If it has changed, you can forward that on to the security admin, which can approve that or not. If that gets to approved, then they can make the changes and then allow the code change to get delivered. So that's the idea there. We'll skip past the security metadata. Okay, so those were the three big areas. I think we'll kind of try and whiz through the smaller areas in the last 6 minutes or so that we've got left. So we have made changes to a number of smaller areas, loads of TLS related things. So first one of those is we've got security expiration detection added into CICS. So there is currently a health checker output from RACF that tells you about security certificates that are going to expire. But that doesn't help you if the problem is a certificate not in RACF, so a certificate of someone you're communicating with, for example. So we've got a new SIP parameter in CICS called cert expiry warn. It defaults to off because it does come with an overhead of us having to check. If you want it on, you can set the number of days away from expiry that we will warn you. And we will then give you a warning if we find a certificate that's about to expire within the specified number of days. So you get a new message, FHSO 1100, which gives you details of the particular certificate. You just get that once, and there's an example of the message at the bottom. We added in support for virtual and shared keyrings. So previously, 6.1 and earlier, the keyring had to be owned by the CICS region user ID, which meant that if you've got thousands of CICS regions, then you either had to have shared region IDs, or you had to have multiple almost identical keyrings. So it's not great having multiple multiple keyrings that are virtually the same as each other, but there are equally good reasons for not having a shared CICS region user ID. So it can be difficult in those environments to adequately manage things. So we've now added support for shared keyring. So that's where you can specify the owning user ID and then the name of the keyring. So you can have ring owner.star or ring owner with the keyring name. And it also allows you to use special user IDs. You can use star or star, which is all the CA certificates. So that's useful if you're a client-only region, so you only go outbound and you just need to verify other service certificates. But equally, you can use sites. So if you're a server region only using site certificates, then you can use the special site keyring. And we did backport that capability to 5.5.5.6 and 6.1. We increased the minimum key strength for TLS cipher keys. So defaults to 1024, but you can specify 2048. But this is also falling in line with increased security, move towards TLS 1.3, higher NIST standards if you're affected by those, essentially everything getting rid of low strength encryption. We added support for sixplex caching for TLS 1.3. So TLS 1.3 is a very different beast to TLS 1.2. We introduced it in CICS 6.1, but there was no sixplex caching capability available at that point. So that has been added in 6.2 now that the base ZOS support for that is there. And definitely, if you are a port sharing set of cloned server regions, the strong recommendation is to always have the sysplex caching turned on. There we go. So what else have we done? We've added support for HTTP strict transport security, that should say, rather than transaction. Strict transport security is mostly of interest if you deal directly with, say, user agents, so typically browsers. So strict transport security is a way of indicating that your server is only to be accessed securely, and the client needs to change its behavior to only send HTTPS connections, and that can include everything inside your domain. If you just interact with other middleware and things like that, then this typically doesn't have any effect. But that's also gone back to 5.5 and above. Only got a couple of things left. So we've got some enhanced certificate diagnostics. So also as part of the work for doing the certificate expiry stuff, we were already picking more information from certificates out. So we've got an additional SO level 2 tracing to provide certificate information when there's problems. So you'll get a buffer of information which will include the chain of certificates involved with a particular handshake failure. We've got a new message for IPIC. If we're unable to acquire the IP con for an unsecured connection going out of the sysplex. So that was a very specific case that we just gave a generic, we can't acquire the IP con before, so now we've given you a very specific message for that. So this is where you're using user auth identifier, so flowing a user ID over an unsecured connection from outside the plex, so essentially somewhere untrusted. We've made a few changes to terminal security. So terminal security, it's a very powerful command, but most of the time you want to do things through your own terminal. And to avoid the need to add security, SPI requirements for everybody to do trivial things for their own terminal, we've allowed you to do operations on your own terminal without security checks, with the exception of a few critical things. So browsing loads of terminals and then changing tracing, naming, and purging options. But basic terminal interaction won't require any security checks if you're doing that on your own terminal. We've altered the security checks for DPLs. For program security, we're already, you're always checking, DFH mirrors, and the user program is the second one. So we really wanted to force the checks for DPL programs to actually take into account the target program. So we've got a new DPL only option on XPPT. So if you enable that and then have DPL only, then it performs the security check on the first program linked by the mirror program. So that's being a slightly lighter weight version of program security. So you do a DPL across, transaction security runs, allows you to run the mirror transaction, and then with DPL only, there'll be one program security check on the first user program that MERS is linking to. So a slightly lighter weight than turning on program security for everything. So it's kind of a stepping stone to getting you towards activating program security. Query security no log is a command that bypasses authorization violations, so you don't get any ICH 408i messages coming out if you query and someone doesn't have access. So there is a potential that could be used to query a lot of things, with it going undetected. So CICS has provided new statistics and monitoring information to keep account of those, so you can at least see if there appears to be any abnormal access attempts related to query security. We've got additional last logon information on sign-on. So I'll whiz through these fairly quickly. But essentially, sign-on has got the same set of parameters that you used to have on verify password. so information related to the change time, expiry time, etc. And that's been used to provide updated messages. So these messages you're very familiar with seeing on other systems these days. Where you log in and then it tells you, okay, well, you were logged in, and the last time you logged in was this date. So we include that information as part of normal signing on, via CICS and via the WUI. And then the last bits that we've continued in CICS 6.2 is our documentation restructure. So we've been using version 6 as a means of dramatically changing the security documentation in CICS. So we've restructured it, and you can see we've got kind of how it works, high level overviews, and then we drop down into having some configuration options and design options, and then real examples of, well, these are the definitions you would use to set your system up in this way to achieve this particular security capability. So this has been an ongoing process. Obviously, you can appreciate there's a lot to cover. So we've been largely focusing on the zero trust items, Java, some TLS bits, and Liberty. So here's just kind of a summary slide of the things that we have changed so far. So 6.1 were things that got changed in 6.1, and then the red areas are areas that we've improved in 6.2. This is an ongoing process, so we've got good feedback from the changes we made so far, and it's certainly something that we were looking to continue on improving over the coming years. Okay, so some of it was a bit rushed through at the end, but we've got there. We're a few minutes over. Hopefully that's okay.
Thank you very much, Mark. It's very difficult to fit this into 45 minutes instead of an hour, which I know this presentation is designed for. Yes. And you've done a very capable job. So thank you very much. Feedback, folks. You can do the QR codes, or you can click on the agenda items and leave the feedback on the website online. The next CICS session's here at 12:30. If you're coming back, which is developing CICS applications using Visio Studio Code with Andrew Twidle. And Jenny He will be your chairperson. You won't have me. So thanks very much for all your time. Thanks for staying the extra, because most of you did. And hopefully see you at some of the other sessions during the week. Cheers, folks. Bye-bye.